questions 11 through 20 on the 2014 Grade 10 AMC 10B. For the consumer, a single discount of N% is more advantageous than any of the following discounts: 2 successive 15% discounts, 3 successive 10% discounts, a 25% discount followed by a 5% discount. What is the smallest possible positive integer value of N? All right, let's just say we're starting with a $100 item. And let's talk about the first one, this guy, 2 successive 15% discounts. So the first discount, you multiply by 85 because you're getting a 15% discount. And that is, of course, $85. And then you're going to do another 15% discount. So another 85 times now 85. And when you do, you get about $72. 72.25. Okay, so that takes care of one. Now let's look at 2. 3 successive 10% discounts. So the first discount you multiply by 0.9, you'll get 90. Then a second identical 10% discount times 90, and you get 81. And then a third 10% discount, and that's going to bring you down to 72.9. Okay, now we look at the last one, a 25% discount, so 75 times 100, and that's 75, and then a 5% discount, so 0.95 times 75, and that brings you to about 71.25. So what type of a discount would be better than any of these? Well, if your discount was, say, 29%, you would bring a $100 item down to 71, and that is a better price than any of these three that we calculated. So a 29% discount would be more advantageous than any of those three discounts listed. So number 11, the answer is C. The largest divisor of 2 billion 14 million is itself. What is the fifth largest divisor? Well, we have to take this big number and obviously divide it by certain numbers. And if you do, it's going to give you divisors. And they've given you the biggest one here. So there's going to be a second biggest, a third biggest, a fourth biggest, and a fifth biggest. Well, there's going to be many, but the fifth biggest one is what we have to figure out. All right. Well, we have to think about what numbers will divide into this. I'm pretty sure 1 can, but 1 will only give you this. How about 2? 2 will definitely divide because this is even. 3 probably won't, and that means I've got to go to 4. 4 will. 5 definitely will, since this ends in a 0. And I think after that, 8, and then so on. So this number divided by 2 is going to give me the second biggest. And that's going to be 1, 0, 0, 7, 0, 0, 0, like that. This number divided by 4 is going to give me my third biggest, and that's 503,500,000. This number divided by 5 will give me my fourth biggest divisor, and that's 402,800,000. And finally, this big number divided by 8 will give me my fifth biggest divisor, and that is 251,750,000. And that is choice C for number 12. 6 regular hexagons around a regular hexagon of side length 1 is shown. What is the area of ABC? Okay. Well, the first thing I'm going to do is try to concentrate on that one side, try to get the length of that one side. And the way I do that is by concentrating on one of these guys right here. So this is 1, and this is 1. So that will allow me to calculate that. And what I'll do is I'll draw it a little bit bigger here, so I'll be able to explain it a little bit better. So there we go. And as labeled, it's 1, 1. Now I'm interested in finding that. Well, the interior angles of an hexagon are 720 divided by 6. So each of those is 120, this interior angle. And if I cut that interior angle in half, like this, then I'm going to have 60 and 60. So let's do that. We've got 60 and 60. This is 60 and this is 60, the angles. And this is, of course, 90 degrees, so that's 30. So we've got a 30, 60, 90 triangle, and you guys have done this so many times now. I'll just call this x, and the ratio of the sides, of course, are 2, 1, and root 3. So x over 1 is the equivalent of root 3 over 2. So this whole side is 2x. That's x and that's x, right? So this is 2x right here. And therefore that's going to be 2x also. So triangle ABC basically has a side length of 4x. Okay, now let's draw that triangle once again. ABC is what I'm referring to. And once I have ABC, I can now figure out the area of it. And let's draw a perpendicular from top to bottom like that. Okay, so we have discovered that the side lengths are a 4x like that. So when I chop the base in half, it basically becomes 2x and 2x. Again, it's equilateral because of the symmetry of this diagram, and therefore this is 60 degrees and this is 30. So yet again, we've got another 30, 60, 90 triangle. And since you're an expert, I'm not going to talk you through it. I'll let you figure out h. And when you do, you'll be able to see that that is going to be equal to 2 root 3x. All right, now we've got enough to figure out the area. Area of ABC is 1/2 base times height. The base is 4x, and the height is 2 root 3x. So that gives you 4 root 3x squared, like that. Now you say, okay, that's great, but what's x? Well, x was over here, root 3 over 2. So we have 4 root 3. That's going to be 3 over 4 when you square it. So that gives me 3 root 3. And that is choice B for number 13. Danica drove her new car on a trip for a whole number of hours. Whole number meaning a integer, positive integer, averaging 55 miles per hour. At the beginning of the trip, ABC miles was displayed on the odometer, where ABC is a 3-digit number with A greater than or equal to 1, and A plus B plus C less than or equal to 7. At the end of the trip, the odometer showed CBA miles. What is A squared plus B squared plus C squared? So initially, we have A, B, C on the odometer, and then we have to add some number. And we don't know what that is. The only thing we know is that it's a multiple of 55 because it's 55 miles per hour times some number of hours. And that's going to give you this XYZ. So, 55, 110, 165, I don't know, ... But we'll see what X and Y and Z are going to be. And then when you add these, you get CBA. Now, obviously, since you're adding something to ABC, C's got to be greater than A. So I think that's pretty intuitive. So I'll just write that here. C's got to be greater than A. Now, C is greater than A. How can you add something to it and then get A? That doesn't make any sense, right? Well, that just means that there's a carry. So C plus Z, it's not going to equal A. It's going to equal 10 plus A, right? Just like in basic addition, you'd carry the 1. That's the kind of situation we have. So C plus Z is equal to 10 plus A. All right, continuing, now let's look at that column. That means that 1 plus B plus Y is equal to B. Well, that's obviously not possible. Y would have to be negative 1. But it is possible if there's a carry. So it's 10 plus B. Okay, the B's cancel, so that basically tells me that Y is 9. Okay, that helps. Let's put Y equal to 9 here. And now I can concentrate on this column. Remember, we had to carry the 1. So we have 1 plus a plus x is equal to c. Now, the only thing I know from here is that the middle digit is 9. All right? If the middle digit is 9, that means I've got to choose a multiple of 55 that has a 9 in the middle of it. And the first one that I get is 495. That happens when the number of hours is 9. Okay, let's work with that. Let's see if that is going to be what makes this whole thing fit. So I've got 495. Okay, if that is the case, then I can go back here. And instead of that, it basically is now c plus 5 is equal to 10 plus a. And that means c is equal to 5 plus a. And then if you look at this one, that basically tells me that 1 plus a plus 4 is equal to c. And that pretty much gives me the same thing, that c is equal to a plus 5. But we also know this very important inequality, that a plus b plus c is less than or equal to 7. A plus b plus c is less than or equal to 7. Well, a plus b plus c, but c is a plus 5, so a plus 5 is less than or equal to 7. So that means 2a plus b is less than or equal to 2. And the only way we can make this work if a is at least 1 is to make a equal to 1 and b equal to 0. And that's it. That's the only way this inequality would be able to be true. And if a is 1, then that means c is equal to 6. So finally, a squared plus c squared plus b squared will be a squared, which is 1 squared, plus 0 squared for b, plus 6 squared for c, and that is 37. So number 14, the answer is D. In rectangle ABCD, DC is equal to 2CB, and points E and F lie on AB so that ED and FD trisect ADC as shown. What is the ratio of the area of DEF to the area of rectangle ABCD? So this is 2x and this is x according to the question. And this is been trisected, so that's 90 originally. So when you trisect it, it becomes 30, 30, and 30. This is a rectangle, so that's obviously 90 degrees, and therefore this is 60. So what am I trying to figure out? The ratio of the area of DEF to the whole thing, ABCD. Okay, well DEF, I'm not sure quite yet, but ABCD is pretty straightforward. That's just length times width, so 2x times x. And DEF is going to be something 1/2 base times height or something like that. Okay, well, let's see what we get. First, let's do a little bit of angle chasing here. If this is 60, then this has got to be 120, this angle in here. And this angle, therefore, has got to be 30 in that triangle. So that basically means that this is the same as that. It doesn't look like it, but that's an isosceles triangle. Okay, so now for the millionth time, we've got another 30, 60, 90 triangle. And I think you're such an expert that you don't need me to walk you through it. And when you use the fact that this is x, I'm interested really in just finding out this one, DE. So DE over x is the same as 2 over root 3. All right. So that is basically going to be what we use. DE, if you just isolate for that, will be 2 over root 3x. Now that's DE, but that is the same in terms of length as EF. So EF is also going to be 2 over root 3x. So that's it. 1/2 base times height. I can use this as the base and this as the height. And when I do, I get 2 root 3x and then x. So there we go. Now I can solve Let's see here, we got the 2's cancel, I just get x squared over root 3, and then on the denominator I get 2x squared. Let's see, invert and multiply x squared over root 3 times 1 over 2x squared. The x squareds cancel, and all I'm left with is 1 over 2 root 3. Alright, most likely they are going to rationalize the denominator, so top and bottom multiply by root 3, and you get root 3 over 3 times 2, 6. Root 3 over 6. And that is A for number 15. Four fair-sided dice are rolled. What is the probability that at least 3 of the 4 dice show the same value? At least 3. So that means you can have 3 of the same and 1 different, or you can have all 4 of the same. All right. So what is the probability? First, let's talk about all 4 the same. Well, the first die, we basically are going to choose some number. So that's fixed. So whatever we choose a 5 or we choose a 3. And then the other ones, if this was, let's say, a 5, the other ones have to all be 5s. So there's 1 out of 6 probability of getting a 5 for the second roll. A 1 out of 6 probability for getting a 5 on the third roll of the dice, and similarly 1 out of 6 probability of getting a 5 on the fourth and final. So this is the probability of getting 4 the same, and that is 1 over 216. Okay, so that's the first part. The next part is this scenario here. We have 3 the same and 1 different. Well, it's very similar. The only difference is that 1 is different. So on the first one, you choose some number. That's going to be the ones that are all the same. So again, let's say I chose 5. The next number, I want it to be a 5, so there's 1 out of 6 probability. Next number's got to be a 5, 1 out of 6 probability. But that fourth number, I do not want it to be a 5. So there's 5 out of 6 probability that it's not a 5. So this is 5 over 216. And then you add these. But before adding them, there's one common mistake, that this actually undercounts. There's 4 scenarios for each of these. Let me explain what I mean. Let's say you had a 5, 5, 5, and 2 when you roll the dice, right? This qualifies as 3 same, 1 different. But you can also have it like this: 5, 5, 2, 5, or 5, 2, 5, 5, or 2, 5, 5, 5. These are counted as different. So this number actually, once we get it, we have to multiply by 4, since there's 4 scenarios for each of those. So this plus this now is my probability. So it's 20 over 216 plus 1 over 216, and that's 21 over 216. If you divide top and bottom by 3, you get 7 over 72, I believe. And that is the answer. 16 is B. What is the greatest power of 2 that is a factor of 10 to the power of 1002 minus 4 to the power of 501? So we want some power of 2, 2 to the power of n, to be divisible by this big number here. All right, so let's see what we can do. I think the first thing is we can factor out this, but before factoring, let's try to make them the same bases if possible. 10 is 2 times 5, so this can be 2 to the power of 1002 times 5 to the power of 1002. That's perfectly allowable. And then 4, of course, is 2 to the power of 2, so it becomes 2 to the power of 1002. All right? No tricks, just straightforward exponent laws. Now I can factor out a 2 to the power of 1002, and that will give me 5 to the power of 1002 minus 1. Yeah, that's it. Okay, at this point, let's concentrate on this. If you remember, if you have a squared minus b squared, it can be factored as a minus b times a plus b. So that's what we're going to do for that guy. It may not look like it, but it is. It really is the difference of 2 perfect squares. So we got this, and let's factor that now. So it's going to be 5 to the power of 501, 5 to the power of 501, minus 1 plus 1. So that is how you factor that. Okay, so now so far, for sure, n can be 1002. It's very clear. So our candidate for n is 1002. And that's one of the answers. Very tempting to choose it and move on. But something tells me that it's not that easy. We got to see if there's any powers of 2 that we can squeeze out of those two guys. Well, I'm curious about this 501 here. Powers of 5, 5 to the power of 1, 5 to the power of 2, and so on, right? There's some pretty good news with powers of 5 that they're very predictable. They always end in 5, and then the last 3 digits sort of alternate. As you can see, so far 125 and 625, but when you keep going, you get 3125, and then you get 15625, and so on. So the last 3 digits always alternate. It's either 125 or 625, 125, 625, like that. When the exponent is odd, it will be 125, and when the exponent is even, the last 3 digits will be 625. 501 is odd, so the last 3 digits of 5 to the power of 501 will be 125. And that's really the only things I need to worry about is the last 3 digits to get sort of an idea of can I squeeze out a power of 2 or not. So I'm going to just put in that 125 minus 1 and then 125 plus 1 like that. Okay, now how many powers of 2 can I squeeze out of there? 125 minus 1 is 124. Is it divisible by 2? Yes. It would become 124 divided by 2 will be 62. Can I squeeze out a factor of 2 from 62? The answer is yes, I can. But then once I get to 31, I can't. So from here, I can actually take out 2 to the power of 2. So that's great. What about 126? 126, can I get a 2 as a divisor? And the answer is yes, you can. But then that's it. Then it becomes an odd number. And then therefore, you can't get any more 2. So I can get a 2 to the power of 1. So now I've got 1002, I've got 2, and I've got a 1. So that would make it 1005. So n is equal to 1005. That's the largest power of 2 that is a factor of that big long number. And that means 17 is D. A list of 11 positive integers has a mean of 10, a median of 9, and a unique mode of 8. What is the largest possible value of an integer in the list? All right, so we have to fiddle around here. A little bit of trial and error involved. This is what I call a time drain question. You don't have any time on a math contest, and they're going to drain your time. Okay, so here we go. Got 11 numbers, right? Yeah. And they're telling me, first and foremost, the easiest one is the median. The median is 9, so just set that to be 9. That's the middle value. And then they told me the unique mode is 8. Okay, well, it's going to be at least twice, so I'll just put it twice for now. And then they want me to figure out what is the largest possible value. So that's going to be my k, since I'm ordering this, obviously, from smallest to largest. And all right, so here we go with this. If I want this to be the largest, I've got to make everything else as small as possible. And let's see how I can do this. Well, let's make everything else as small as possible. Do they have to be unique? No, but the thing is that the mode is 8, so I can't make the same number 3 times because the mode is 8. So nothing in this example can appear more than twice. So I got to make it 1, 2, 3 in terms of small as possible. 10, 11, 12, 13, and k. All right. So adding these up, 1 plus 2 plus 3 plus 8 plus 8 plus 9 plus 10 plus 11 plus 12 plus 13 plus k all over 11 is got to give me an average of 10. So if I do this math here, I get 77 plus k is equal to 110, and therefore k is 33. Okay, 33 is one of the answer choices, but I got a feeling that perhaps it could be 35. Well, the good news is that we got the second largest answer. So let's see if I can get 35 somehow. And with a little bit of experimentation, you will actually see that it is possible to get 35. How you do that is by making the numbers the same median, of course, and 8 is the mode, but you got to add one more 8. And then the rest will be similar. You can actually make these now 1 and 1 because it doesn't affect the mode. The mode is 3 this time, 3 8s. And then this one can be 2 of these guys. And actually you can put 2 of 9s also, since that won't affect the mode, and then 2 of these guys, and then 1 11. So it takes a little bit of fiddling around. Now let's add these guys. When you add all of those, you get 75 plus k over 11 is equal to 10. So that means 75 plus k is equal to 110, and therefore k is 35. So we had to fiddle around a little bit longer with the question in order to get the right answer. So number 18 is E. 2 concentric circles have radii 1 and 2. 2 points on the outer circle are chosen independently and uniformly at random. What is the probability that the chord joining the 2 points intersects the inner circle? So we've got one circle and we've got another circle like that, concentric. They have the same center, and the center is somewhere here. So what is the question asking? You put 2 points on the circle, say here and here, and then draw a chord. It's supposed to be a straight line. Does that chord intersect the inner circle? And the answer is no. So we wanted to intersect the inner circle. Okay, well obviously it would be like this. That definitely intersects. So they're saying, what's the probability of you being able to draw a chord so that it intersects the inner circle? Okay, well obviously it's got to happen in a way so that it touches the circle at least once, and that is the only way to do it. And similarly on this side, as you can see, that's the only way to do it. Anytime you have the points in this range or in this range, it will create a chord that intersects that inner circle. But if I draw 2 points outside of these lines, say here or here, those will not intersect. So all I really have to do is figure out how much of the circumference does this arc and this arc make. That will basically be the answer to the question. Okay, so how do I do that? Well, just draw a line from here to here, the center to here. And if I can figure out that angle, I'm set. I'm done with the question. Okay, I'm pretty sure I can do that. Let me just extend this line here. And let's label some things. This is the radius of the small circle from there to there, and they've told me that's 1. This is the radius of the big circle, and they have told me that's 2. And therefore, by Pythagoras, I can figure out this. That's going to be pretty straightforward. 2 squared is equal to 1 squared plus x squared, where that's x. And therefore, x is going to be 4 minus 1, which is 3, and therefore x is root 3. So since x is root 3, and the 30, 60, 90 triangle you are an expert on, this is a 30, 60, 90 triangle, because those sides represent the ratios of a 30, 60, 90 triangle. And in particular, this is 30 degrees, this is 60 degrees, and that's 90 degrees. So that means this whole angle in here is 120, since that would be 60 also. So this is 120 degrees, and the same thing would hold true over here if you did it over here. So that means this represents that part, 120 over 360 of the circumference, which is a third of the circumference. This blue segment. And by symmetry, you could do the exact same thing and show that that also represents 1/3 of the circumference. So going back to our original, this part and this part, therefore the red represent the other 1/3 of the circumference. And that is the segment of the circumference where we draw our 2 points on. That allows us to make those chords that intersect the inner circle. And that's it. 1/3 is the answer. So it's a cool question. I like it. Number 19 is D. For how many integers? X is the number x to the power 4 minus 51 x squared plus 50 negative. All right. X to the power of 4 minus 51 x squared plus 50, and we want this to be less than 0, negative. Well, I can factor out an x squared, and if I do, I get x squared minus 51 plus 50. Now, 50 is positive, and x squared is going to be positive for anything you put in when you square it becomes positive. So the only thing that could be negative is this x squared minus 51. That is the only thing that could be negative, and that's going to indicate this whole expression, whether it's positive or negative. Okay, so we now have to concentrate on this. If x squared is less than 51, which is basically what it means, that means x is going to be anywhere from 0, 1, 2, 3, 4, 5, 6, and 7, I believe. If it goes greater than 7, if it's 8, 8 squared is 64, so that's not going to work. But 7 squared is 49. So these are the numbers that are our candidates. We're not sure how many of those actually work, but those are possible values. So here's my expression. And for each of these, I will put in x. Now, the good news is that we actually have quite a few of these, and all of these are plus or minus, remember. Don't forget the fact that they're plus or minus, because when you take the square root, you can have +1 or -1, +2, -2, like that. So let's make a little table, and let's start. So 0, ±1, ±2, and so on. And the good news is, if you put in the positive value, it's going to come up with the same result as the negative value. For example, if I substituted x equals 2 into this expression, the result is the same as x equals -2, because you're basically squaring them. So that saves us a little bit of time. ±3, ±4, ±5, ±6, and ±7. Okay, here we go. When it's 0, you get 50. All right, well, that's no good. We want it to be less than 0. So that doesn't work. Okay, so we've got these guys left, and there's 14 of those numbers. Correct? All right. So 14 is one of the answers, but let's see. When x is 1 and you substitute it in, you get 1 minus 51 plus 50. And 1 minus 51 is minus 49. And minus 49, or sorry, 1 minus 51 is minus 50. And when you add 50 to it, you get 0. Okay. Well, 0 is not less than 0, so these guys are out. So now I am down to only 12 candidates for my answer. Okay, so this is gone, this is gone. So I will just put in the numbers instead of walking you through it. You don't need to hear me do all this stuff. I'm just figuring out the values of each of these, for each of these actually. So here we go. When it's 2, we get minus 138. When it's 3, you get minus 328. When it's 4, you get minus 510. When it's 5, it's minus 600. Minus 490 for 6. And then for 7, you get minus 48. So all of these guys produce negative results. And how many are there? Well, there's 12. So number 20, the answer is C.